Welcome to Flipped Lesson 110 for the 6th grade. Today we're looking at the idea of symmetry. And as we look at different shapes, symmetry can come in a multiple ways. And in that sense, we can find that some shapes have lots of symmetry, some shapes just have a little bit of symmetry, and some shapes have no symmetry at all. Right? And so let's go ahead and dive right into this. As we look at symmetry, first of all, we can see that we have what is known as lines of symmetry. A line of symmetry is where you can draw a line from really a vertex or a point on one of the sides so that it will cut a shape in equal halves. And in those equal halves, then you're able to then fold your shape across that line of symmetry, and you're going to have the exact same shape or the exact same amount of area on both sides. Right? So for example, we have our green line here, and it cuts through our isosceles triangle, and what that means is that this side is congruent to this side. They're the same, right? And these two triangles are, if you look at that green line being there, they're really the exact same amount of area, and if I folded it on that green line, they would be the same. And so that's one way to look at symmetry. Right? However, some shapes can have multiple lines of symmetry. So for example, we have our rectangle. All right, and as we look at our rectangle, we can start to draw lines that show the symmetry, right? And so I can take a line and I can divide it in half this way, and hopefully that's about half. And then I could also take a line and I could draw it this way in half, and we could say that that is symmetrical because you can fold it or you can overlap it together and it's going to be the same. All right. So what symmetry is not, right? I'll try and use a dotted line to say, okay, this is wrong. Right? I'll even make it red, right? Because we know it was red. Is, right? I can draw a line like this and say, okay, it's a little bit off in this corner, and say that I've divided my rectangle in half, and that would be true, right? But it's not a line of symmetry, because if I were to take side A and fold it across this now red line, it would not match up perfectly with side B, right? This corner would end up folding over and it would be over here somewhere, right? And so it's not symmetrical because of that concept, right? Right, so symmetry is when you fold it over, they're going to be exactly the same, right? Corners are going to match up, everything's going to match up perfectly, all right? As you look at this, I'm just going to let you look at this picture and just kind of take this as a sample, right? Which of these triangles doesn't appear to be symmetrical? Take 30 seconds, all right? I'll put some letters on them. We'll call them X, Y, and Z, and you can write that down as a sample. This is a good one to start testing our first idea. So our first idea is all about lines of symmetry. The second idea in symmetry is what's known as rotational symmetry. Rotational symmetry is where you pivot around a central point, and as you pivot this shape, right, it rotates and the shape doesn't really change, and it's still symmetry, right? It's still matching in that sense. But when it comes to rotational symmetry, we get a little bit more precise. So as we look at our figure on the board, what can help is, let me color this side right here nice and blue. That doesn't appear very well. Let's try red too. All right. I don't know how much better that looks either, right? All right, let's pretend this side is colored, right? If we were to take this square and we were to rotate it, right? This is a 45-degree turn. And if we rotate it, we would realize that the red side is now right here. Right? And while these two squares are congruent still, because obviously all we're doing is rotating it, we would not say that they're symmetrical, because this one has, right, we have a flat side here, while this side, the diamond shape, is what we're looking at in terms of a square. And so they're not symmetrical because it hasn't gone back to its original shape, which is this shape right here, right? But if we continue to turn it, right, if I turn it a full 90 degrees, right, that would mean the red side is up here, and we can see that this figure looks the same as this figure, and so this is where we say it has rotational symmetry. So that as you continue to rotate it, right, after you do a rotation beyond a complete 360-degree rotation, right, as you continue to do rotation, every time the original shape appears, such as this one right here, that would make it symmetry, right? And so it rotates, rotates, symmetry. So you're always looking for the original, right? So if this is your original, 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 original here, and you get that idea, all right? All right, here we go. Here is your second sample then, looking at rotational symmetry. So you're going to look at these figures and see if you can figure out if they have rotational symmetry. Okay. One of the easiest things to do in helping you is to create what I would call a point of origin, right? Or color one of those sides. It really helps you give you that visual to understand rotational symmetry. So I'm going to throw some colors up there real quick, and you can think about the symmetry there, all right? And I'll color this side in. Helps you understand the rotation going on. All right, that's it for lesson 110.